So for this part, we want to think about their rates of change. And with a linear function over here on the left-hand side, there's really only one thing you want to think about. A rate of change, aka slope, it always stayed the same. So the word we use for that is the word constant. Your rate of change is going to be constant. Maybe up 2 over 1, up 2 over 1, up 2 over 1. You do the same thing over and over and over again. That's because that rate of change is constant. But with an exponential function, your rates of change don't have to be constant. And they can be two things. Your exponential functions are able to have both a positive, or a negative rate of change. So we have positive rates of change. That's where something is growing. Remember, we talked about that a few minutes ago. And then we have negative rates of change, and that's when something is basically decaying. So a positive rate of change, you're going to hear this coming up here a lot. A positive rate of change is what's called exponential. So I'm just going to abbreviate exponential growth. Exponential growth. We're growing. All right. And what's going to happen is, and this might not make sense yet, but it's going to make sense in the coming days, is that to get that positive rate of change, what you're going to be doing is you're going to keep what you started with. That's the number 1. The 1, like think about 7 times 1. It keeps the 7. The 1 keeps what you started with plus the new amount that you're about to grow. So that's your R. So 1 plus R. Let me make that a little more neat here. 1 plus R. That's your positive growth, your positive rate of change. For a negative rate of change, that's called exponential decay. We're decaying now. And so instead of 1 plus R, you could probably take a guess. It's going to be 1 minus R. Oops, I still did plus. 1 minus R. So 1 minus whatever that rate of growth is. So that's a key difference here between the positive growth, exponential growth, and negative rate of change, exponential decay. So to see the two differences between your exponential growth and decay is really, really important. So these two expressions are going to come, we're going to come back and use them on the next couple of days. The expression right here and right here.